Let's do a few examples of multiplying some of these polynomials that we were looking at in the notes. So we'll start off with some simpler ways of multiplying. Multiplying a monomial times another polynomial. So something like this, 3x squared times 2x cubed minus 5x. If you remember your distribution property, since this is separated by multiplication or subtraction, by addition or subtraction, we can just think about distributing this 3x squared to both of these terms. So I'm going to multiply 3x squared, in this case, times 2x cubed, and then minus 3x squared times 5x. And from here it becomes not too hard. 3 times 2 is 6. X squared times x cubed, remember your rules, you should add the exponents, so this will become x to the 5th. And then here I'll have 15x cubed. Again, just multiplying the constants and then adding the two exponents together. And of course, I can continue to expand on this as much as I want. So if I take something like negative 2y cubed, I can multiply this by a trinomial, for example. So negative 2y cubed times y squared plus 3y minus 5. Again, I'm just going to distribute this, but I'll distribute to all three terms this time. So I'll get negative 2y cubed times y squared plus negative 2y cubed times 3y minus, actually this will be negative 2y cubed and negative 5, so this will be a plus 2y cubed times 5. Or this step, if you wanted to write negative 2y cubed times negative 5, that would work as well. You'll still end up with a plus at the end. So this will be negative 2y to the 5th. Again, I'm adding exponents because I'm multiplying these two. Negative 2 times positive 3, this will be minus 6, and then y cubed times y to the 1st. 3 plus 1 is 4, so y to the 4th. And then 5 times 2, of course, is 10. And then the y cubed has nothing to combine with. And then the last thing I want to do is look and see if I have any like terms, anything that will combine from here. It looks about as far as we can go, so this is a good answer. So that's multiplying monomials times another polynomial. What gets tricky is when we try to multiply two polynomials together when one of them is not a monomial. So for example, something like this. And again, if you look in the notes, you'll kind of see this method we're going to use, the FOIL method, in a little more detail. I'm even going to work through some examples here. The FOIL method, remember, says that we want to, if we have two binomials multiplying times each other, we want to multiply the first two terms, the outer two terms, the inner two terms, and the last two terms. So the first two terms, x times x. The outer two terms, so x times negative 3. The inner two terms, so 5 times x. And then the last two terms, so 5 times negative 3. Essentially, all you're doing in a FOILing process is you're multiplying every part of the term, so every figure, every term in each of these figures by every other term on the other side. So x times x and negative 3, which you get right here, and then 5 times x and negative 3, which you get 5 times x and then 5 times negative 3. So basically every part of the multiplication gets multiplied by every other part in the multiplication, at least with respect to the two different sides here. So then we just finish this out. This is x squared minus 3x plus 5x minus 15. And then we just want to combine the like terms. So 3x and negative 3x and 5x are like terms. And we'll get this, x squared plus 2x minus 15. The more of these you do, you can probably skip these middle two steps and maybe even just go straight from here to here. You get really used to doing the full method and you can do a lot of it in your head. So let's try another one. So 3x squared plus 5 times 2x squared plus 3x. Again, I'm multiplying the first two terms together, so 3x squared times 2x squared, so that would be 6x to the 4th. Then the outer two terms, so 3x squared times 3x, that would be 9x cubed. The inner two terms, 5 times 2x squared, so this would be 10x squared and then the last two terms, 5 times 3x, or 15x. And then I just want to combine any like terms that I might have. Nothing in here is like terms because they all have different exponents, so this is actually my final answer. Now I can extend this idea of FOIL to more than just binomials. So for example, I could take a binomial times a trinomial. Something like this, y minus 2 times 2x squared plus 5y minus 3. Again, the idea is to take y, or every part of this term, every term from this expression, I should say, and multiply this term times every term in the other expression. And then do the same thing with the negative 2. So I'm taking this negative 2 and multiplying it times every term in the other expression. So I should end up with 6 different multiplications that I'm doing here. So that, again, is the idea that you can make these as big as you want as long as you follow this rule that every term in this expression gets multiplied by every term in that expression. Then you can FOIL out as many, as big of polynomials as you want. So let's do this one at a time. We should have 6 terms here at the end. So y times 2y squared, that will be 2y cubed. Y times 5y, that will be 5y squared. Y times negative 3, that will be minus 3y. Negative 2 times negative 2y squared is minus 4y squared. Negative 2 times 5y will be minus 10y. And then negative 2 times negative 3 will be plus 6. And then the last thing I want to do is just go through and combine any like terms. Let's see. The 2y cubed doesn't have anything else to combine with. 5y squared will combine with 4y squared, with the negative 4y squared to give me a plus 1y squared. Negative 3y minus 10y is negative 13y, and then plus 6, and that should be a perfectly good answer. So this is one that you might see. Another common one to do is a trinomial times a trinomial, which if you can think about it in your head, this should end up with 9 terms after the FOIL, and I'll show you why. So something like this, 2x squared minus 3x minus 5, well, let's do plus 5, that's what I have written down here. And then x cubed plus 5x squared minus 7. Again, the idea is to multiply everything, all of the terms from this expression, times every term in the other expression. So the 2x squared gets multiplied by all 3 of these terms. Likewise, the negative 3x is going to get multiplied by all 3 of these terms. And then the 5 also is going to get multiplied by all 3 of these terms. So you can see where 9 comes in. We have 3 things times 3 other things. We'll get 9 terms whenever we finish here. Alright, so let's start with the 2x squared. 2x squared times x cubed, that will be 6x to the 5th. 2x squared times 5x squared, that will be 10x to the 4th. 2x squared times negative 7 will be minus 14x squared. And now on to the negative 3. Negative 3x times x cubed will be minus 3x to the 4th. Negative 3x times 5x squared will be negative 15x cubed. Negative 3x times negative 7 will be plus 21x. And then I'm going to continue down here because I'm running out of room. 5 times x cubed will be positive 5x cubed. 5 times 5x squared will be 25x squared. And then 5 times negative 7 will be minus 35. So again, I just want to go through and combine any like terms now. So there's no other x to the 5th term, so the 6x to the 5th will stay. 10x to the 4th minus 3x to the 4th. That will be 7x to the 4th. Negative, let's see, I have some with cubed. Let's do those. Negative 15x cubed plus 5x cubed will be negative 10x cubed. Squares, I have 2. Negative 14x squared plus 25x squared. This is going to be 11x squared. And then, do I have any constants? Oh, I have my 21x, right? 21x, so that stays by itself. And then my constant is negative 35. So you can see my answer wasn't necessarily 9 terms long because I had some like terms But still, it's a pretty long polynomial. And you could definitely tell the bigger you get with these, it starts to take a lot of time. So if I did a 4-term polynomial times another 4-term polynomial, I have 16 terms to deal with. And so you can definitely see where it's easy to make a mistake. So when you do these, do them nice and slow. Make sure you get the exact numbers that you want to get. And then when you're combining them, be really careful as well, because it's easy to make an arithmetic mistake or an algebra mistake while you're going through these. Now the interesting thing about the FOIL process is that we can use this with some multiplications. It doesn't look like we should be able to use FOILs. So for example, something like this. So x plus y minus 2 in parentheses times 3x minus y minus 3 in parentheses. Now there's a few ways you can do this problem. I could go ahead and distribute out this plus sign here and get x plus y minus 2, trinomial. And then distribute out this negative sign here, minus y plus 3. And now I have 2 trinomials to multiply. But we already saw that multiplying trinomials can be a little laborious. It can be a little long. It can take a little long to do. So we want to know, is there a more efficient way to do this? Is there a way that I'm going to have to do fewer computations and less likely to make a mistake? In fact, there is. I can just think of this as a FOIL of 2 binomials, where this is my first term, this is my second term, this is my third term, and this whole thing is my fourth term. And if I think of it like this, I can just do my regular FOIL. Since this is in parentheses and this is in parentheses, I'm just going to think of those as one single thing that I'm multiplying by. So the same way we did when we were multiplying something simple like this one that we did at the beginning. 1, 2, 3, 4, 1, 2, 3, 4. Let's see how this would work. The first two is normal, x times 3x, that'll just be 3x squared. And then I want to do the outer one, so x times negative y minus 3. So I'm just going to write it like that, minus x times y minus 3. It's a negative because this is positive, and this whole thing I think of as being negative. And then I'll just simplify this later. Inner terms, 3x times y minus 2. So 3x times y minus 2. And then the last thing, y minus 2 times y minus 3. This will be negative though, right? Because this is a negative term, and this is a positive term. So positive times a negative will always be negative. And as you see, we still have some computation to do, but it's not as much stuff going on as when we were doing the trinomials. And the computations are generally easier, at least for a problem like this. So let's just simplify this. This will be 3x squared, and then if I distribute that x, the negative x, I'll get negative xy plus 3x. If I distribute that 3x, I'll get plus 3xy minus 6x. And then I just need to think of this as going to be minus y minus 2 times y minus 3. So y squared minus 5y plus 6 is what I'll get if I FOIL all of that together. And now I just need to simplify again. So 3x squared minus xy plus 3x plus 3xy minus 6, and then minus y squared plus 5y, and then minus 6. From here, I just need to combine any like terms. The 3x squared won't combine with anything. Negative xy plus 3xy, that'll be plus 2xy. 3x plus negative 6x, that'll be negative 3x. The y squared won't combine with anything, and then we will get 5y and the negative 6. So looks like we're in good shape here. Now again, this is a lot of work, right? And it probably ends up being around the same amount of work we would do if we multiplied 2 trinomials. But the calculations that we're doing are not, there's not maybe quite as much going on. So this is the way I prefer to do these problems. If you prefer to do it the trinomial way, that's perfectly fine. They both get you the exact same answer. Like I said, with a lot of these problems, you'll eventually develop a preference of the way you like to work the problems. And the more times you work it the way that you like to, you become really comfortable with doing it that particular ways.